Hello everyone, I am Gökay Şimşek. Welcome to my presentation from my room for MECO 2020 conference. I hope all you are healthy and I can get your attention. Let's start.
The topic of the presentation is Parking IoT, an IoT architecture to collect availability data from parking lots. It is written by me and Mehmet Tahir Sandıkkaya from Istanbul Technical University. Topics of the slide I will talk about. I will talk about the problem, current solutions, what we propose, and the results of the solution. On the weekends or during holidays, finding an available parking slot takes lots of time in city centers. It's due to lack of parking slots. Increasing the number of parking slots is not possible, but optimizing finding available parking slot is more possible to solve. There are products that use surveillance systems. Those products require always-on cameras that constantly consumes network, energy, and processing power highly. Besides, it's not suitable for parking lots where lots of obstacles exist between parking slots. The obstacles may be trees, buildings, or other cars. There are also IoT solutions like parking bay sensors. It uses repeaters to transmit data to the sink node, then to the internet from the sink node. The solutions resemble star topology, and it increases costs and energy consumption. It's a drawing of the proposed solution for linear topology. Blue CPUs below parking slots represent IoT nodes. Microcontrollers that is connected to the internet represent sink nodes. And arrows represent data transmission routes. I will simply explain how it works with an example. When the police car left the parking slot, IoT device below the police car detects the car leaves and sends data to adjacent nodes. The adjacent nodes send data to only one direction. The data is transmitted from node to the sink node. Finally, the data reaches two sink nodes if there are no data loss while networking. As you have seen in previous slide, nodes only connect to adjacent nodes. The data is transmitted node to node. The distance between nodes is only a few meters long. Thus, device capability requirements and energy consumption is low. The data has lots of duplications that can be aggregated. Data which is measured periodically can be turned into statistics. To make efficient data aggregation, there has to be more than one node's data. In order to have enough data, data is kept for a while. The aims of the simulations are proving energy consumption gain, determining the relation between energy consumption and delay loss over node count, the behavior of the system in linear, star, and ring topologies. There are 6 charts that I briefly evaluate results for every chart. There is the request count chart on the left. The possibility of sensing data is independent for every node. Thus, as node count increases, request count increases as well for all 3 topologies. But for linear and ring topologies, request count increases more rapidly. It's an expected behavior due to the data transfer route of linear and ring topologies. For star topology, the data is transmitted directly to the sink node. For other topologies, data is transmitted to the node till sink node. There are throughput chart on the middle and goodput chart on the right. Throughput and goodput has a correlation with request count.
There is a network utilization chart on the left. The network utilization is connected to average throughput per device and device's networking module capacity. For all node counts and topologies, the networking capacity is the same. Thus, the chart has a correlation with throughput. There is the end-to-end chart on the middle. The data transfer route and data retention increases end-to-end delay for linear and ring topologies. There is the energy consumption chart on the right. Although request count and throughput for linear and ring topologies are greater than star topology, the transmission distance is much shorter. And while transmission length increases the energy consumption linearly, transmission distance increases exponentially. As a brief conclusion, the study can also be seen as a networking optimization for IoT network with linear and ring topologies, as well as a finding parking solution system. Thank you for your time and attention.